Yeah, what's up, everyone? Trust you're doing very good. Welcome to your tech. So today we'll be looking at what's this so called? Pure sine wave and modified sine wave. Their differences. Number one is pure sine wave give you a very clean output. You understand? That's why sinusoidal wave. Let me show you the wave I'm saying. It's not like this. Sinusoidal. You understand? But if it is modified, it will be in block form. You understand? It's not that the modifier is bad. It's just that there are some electronic devices that are very sensitive to it. That's why when you plug it, you'll be hearing some humming sound and the rest. So, but the purpose of this video is how to identify it. There are a lot of ways to identify, you understand? But because at times there are some that we even put sticker like this, put the sign of pure sine wave and write it. By the end of the day, it can be fake, you understand? So how do you identify? The best way, which is the reliable way, is to get an oscilloscope. You understand? Oscilloscope is the best one. There are some handheld portable, there are some big one like that of the lab type. But the challenge is the cost for basic DIY, especially for people in Africa, is not really easy for something you're not doing as a full-time job. So buying it may be not really necessary. But how do you identify it? Very fast, very simple. Number one, from the weight, a pure sine wave is more heavy than that of the modified sine wave. It's more heavy, you understand? Then another quick way is, if you have a fan like this, if you have a fan like this Hawks fan or any fan that use big coil, if you plug it in, by the time you test it, you see the modified sine wave. When you plug a fan or you plug fridge or anything like that, you'll be hearing humming sound, like you'll be hearing that sound. So that fan is trying to tell you that this signal is not clean. Even though laptop, when you plug it, they will work perfectly, just that you'll be hearing that humming noise, and it's not too good for electronics. Over a long time, it can really affect them. You understand? So that's one of the way. So if you want to buy it, let's say they have a fan there, you can just plug it, you hear the difference, you know. Then another quick way, let's say you have one with you and you want to be sure, is this thing truly pure sine wave or modified? Now I have two set of I have some with me here. So this one we are saying is modified. This is modified. Now look at their differences. You can see this transformer is high frequency. You can see it here. The pure sine wave. This one is pure sine wave. You understand? It has it. If you see there is capacitor, but there is just more. There are some capacitor here too. There's capacitor here. You understand? But if you look at this one, you can see some more core, some more features. But one of the surest way to identify, you see this board we are seeing here, every pure sine wave has it, especially circuit like this. They must have it. If you cannot see this board, forget it. What you have is not pure sine wave. It's not. So for people that even build pure sine wave, especially locally here in Africa, Nigeria, and the rest, when they build, they used to include this board. There is a way they integrate it, and it will give them a pure sine wave output. You understand? So in case you have one, because there is no way you go to market, you want to go and you tell that person you want to lose it to confirm. No, they will never agree. But in case you have it with you and you want to be sure, just lose it, compare it, you will see the difference. So you can see, and also the MOSFET on these ones, they are more rugged than the one on the modified. You understand? So those are the difference. So irrespective of the one you have, just work with it. But just know that whenever you want to power things like fridge, you want to power fan, all these big fan with big coil and the rest, you understand, try to use pure sine wave to make your system perform well, and it will even reduce the startup surge. What do I mean by startup surge? For example, when you plug a fridge, let's say a fridge is rated for 150 watts. You see that 150 watt, that is the continuous power, but at every startup time, it can go times 3, times 4, times 5. There are some that can even go as times 5 or even higher. So let's say a fridge that is 200 watts and it goes times 5, that is 1000 watt spike. You understand? So that means at that seconds it will go to 1000. If that inverter cannot do that surge, it will fail. You understand now? That's why you see the inverter will trip up and you'll be like, what is going on? The problem is because it's modified. Although your battery size too matter, your inverter capacity matters too, because you don't expect to have a 1 kV inverter and you want to use it to power a big freezer. It's not possible. Because mind you, the rated, forget the rubbish they are writing on it, all this 2000 watt, a lie. What is on it is not up to that 2000. So in your mind, just plan something like, let's say 1000 to 1000 plus. If you want to be on safer side, just load it within 500 to 800 watt. But for this 2000 watt, this particular pure sine wave, now even though your fridge go times 6 times 7, it will handle that surge and it will run more smoothly than when you are using modified sine wave of 2000. Don't worry, I will do a video on that. We'll test the two of them. I will plug it on modify, I will plug it on sine wave, and you'll see the difference. That switch off, so let's on it and let's check. You can see that. So it's working now. This camera that is making the fluctuation. It's not the light, you can see it. If I off it, you can see it now. If I on it. So the system is working now and everything is good to go. So we've succeeded in building this. So let's check with the fan. So I have an AC fan here. Let's check with an AC fan. Let's plug. You can see it. You can see that it's working immediately. Let's turn it off. I've turned it off now. I turn it off. And if I turn it on, check the fan. You can see it now. Now, let me power with the modified sine wave so that you see the difference. So that you see the difference of pure sine wave and modified. You can see the fan now. Huh? The nameplate is not even here. You can see this is the 20 inches fan. And the watt, 135 watt. Okay. So let's plug with this. Our battery is low, but hopefully you can still power it. There's a 1 kV that is inside this. And let's plug. Let's on it. You can hear the noise. I believe you can hear that. Let's off it. I believe you notice that noise. Calm down now. Let me play it so that you know the difference between pure sine wave and modified sine wave. Remember, check the fan. It is 135 watt, but it's because it is a coil. You understand? And we'll plug it to this. We want to compare pure sine wave and modified. Check. You can hear that noise. You can see that it's even struggling. Let's go again. You can see the way it's struggling to start it up. Now let's go to pure sine wave. Let's plug and let's on it. You can see it now. Do you hear that stupid noise again? You can see that is the sound of the breeze. Can you see that now?